I am Dr. UP Patil, Department of Chemistry, Arts, Commerce and Science, College Pulus. We are studying unit operations. The last part of this unit is in progress. Previously we studied separation techniques including magnetic separation method and Proth flotation method. Now the next part of this unit is distillation. We have studied different kinds of distillations, and now after discussion of Proth flotation method and then distillation process, we studied vacuum distillation, and now I am going to start with steam distillation. So see here, steam distillation. What is the meaning of steam distillation and why it is useful? Steam distillation is a compounds which are generally heat sensitive, steam volatile and immiscible in water are purified by steam distillation method. In this method, steam from a steam generator is bubbled through a heated flask containing the mixture to be distilled. The liquid boils when the sum of vapor pressures due to organic liquid and due to water becomes equal to the atmospheric pressure. The atmospheric pressure, in which water pressure and organic liquid pressure, organic liquid pressure must be lower than water pressure. Then the organic liquid vaporizes at lower temperature than its boiling point. The mixture of steam and vapor of more volatile compound is cooled, condensed and collected. The compound is recovered from water layer using a separating funnel, and this is the method how to separate out steam heat sensitive compounds. One example is here, that is aniline. It can be separated from water. The advantage of this method is that it is easier to control the temperature of the steam than the surface of heating element and allows a high rate of heat transfer without heating at a very high temperature. To obtain good results, here more than one condensers may be connected in series. Steam distillation of various aromatic herbs and flowers can result in two products, an essential oil as well as watery herbal distillate. The essential oils are often used in perfumery and aromatherapy, while the watery distillates have many applications in aromatherapy for food processing and skin care. So just what is steam distillation? Just I discussed is open. It is used generally to separate heat sensitive components in a mixture. This is done by passing. Once again, I am repeating the same thing. It is this process done by passing steam through the mixture, which is slightly heated to vaporize some of it. The process establishes high heat transfer rate without the need for high temperature. The resulting vapor is condensed to afford the required distillate. The process of steam distillation is used to obtain essential oils and herbal distillates from several aromatic flower herbs. Just I discussed at this point. Steam distillation analogous to simple distillation. The main difference being that steam or water is used in the distilling flask along with the material to be distilled. Experimentally, the setups are arranged more or less the same, with small difference being how the steam is added to the flask, either indirectly if a steam line is available in the building, or directly by boiling water in the flask. In diagram, it has been clearly shown that in container water is taken there, it is vaporized along with organic components, then it is collected in another flask called as compound to be distilled, where it is given there, and then it is collected, distilled liquid is collected in container. This is a diagram used for steam distillation. Mostly organic compounds which are heat sensitive, volatile. For them this process is used. Now the next distillation method is spinning band distillation. It is used to separate a lower boiling point material from a higher boiling material. Spinning band distillation, first sentence is important. It is used to separate a lower boiling material from a higher boiling material. Those materials which are having higher boiling points, and if it is mixed with the material which is having lower boiling points, for them it is very convenient to use spinning band distillation. Spinning band distillation creates close contact between the vapors and the condensate in a dynamic process. It uses a helix spinning at high speeds inside the distillation column. The spinning band forces vapors into close contact with the condensate on the wall of the distillation column. This contact takes place in a very thin layer that is refreshed thousands of times per minute. As a result, spinning band distillation gives a very efficient separation in a short distillation column. So this is our spinning band in general idea given there. Those which are heat sensitive or high boiling, highly viscous fluids, for them this method is used. It is very simple. Generally the process, that is, the column contains rapidly rotating motor driven spiral band. Inside that there is a rotating band called a spinning band which rotates very vigorously. It is connected to the motor. Spiral band is there. It is either made up of from polymer coated metal, stainless steel or platinum. Any of this material is used to make this bond. The rapid rotation of the band in contact with the walls of the steel gives intimate mixing of descending liquid and ascending vapor. Further, the screw-like motion of the band drives the liquid towards the steel pot and reduces hold up. In such a system, there is a very little pressure drop and very high throughputs are possible with high efficiency. Just I discussed in the spinning band distillation, it contains spinning band fractionating column which contains a rapidly rotating motor driven spiral band. Just I repeating the same thing. Important thing, inside that there is a rotating spinning band. The distillation flask is filled not more than half full with sample liquid to carry out spinning band distillation. Then spinning band fractionating column, condenser, thermometer, etc. are placed in a position by taking usual precautions. The distillation flask is heated as usual. When steady state is reached, that is temperature at the top and still is same, the component having low boiling point will first distill. Collect the distillate. When low boiling component distills off, continue the heating to get next component. If suppose two organic components are present into that, then the first component which are having low boiling point will come first, and then the second one remaining can be separated from the flask. So this about general procedure called as spinning band distillation. Details are also given here. What material just I discussed. This is a diagram showing that the presentation at the base there is a distillation flask which is provided with thermometer. Then it is connected with the column. Inside the column there are spinning bands. Outside that there is a glass tube. Into the glass tube these spinning band columns are fitted. Then thermometer is connected to this is to control the temperature or to identify the temperature. In upper part of this condenser there is a water circulation process which is generally referred as condenser, and motor is shown at the top of this which rotates the spinning band condenser, and then the magnet is provided to it to rotate this frequently. And at the right hand side one column is shown. There is a column is connected to distillate out organic components. So this is about the diagrammatical presentation of spinning band. Now it turns towards the next point, that is applications of this spinning band distillation process. Spinning band distillation may sometimes be used to recycle waste solvents which contain different solvents and other chemical compounds, generally used to separate out waste solvent to recycle it. For example, suppose methanol is there, or acetone, which are heat sensitive, or any other that is cyclohexane, then which are very nice organic solvents, cyclohexane, n-hexane, or many others. That ethyl acetate is another one that can be separated. If it is used, once used, then it is necessary to separate out them from the compound, and for that purpose the spinning band column distillation column is used. Spinning band distillation process is used. So this is about the applications. Now turns towards the next and the last part of this unit, that is types of fractionating columns. Here are different types of fractionating columns are shown. A, B, C, D, total 5 columns. Fractionating columns, that is columns connected to the container, or we call it called as a flask, and it is heated, then the solvent is separated and water circulation is provided. We know that the simple columns available there, then that which are available in our laboratory. Vigorex college is not there. Then pear shaped bulb, Hempel columns, these are different kinds of columns are used. The main intention to utilize this column for fractionated column for separation of mixtures generally. Fractionating columns is designed to provide a larger surface area and allow the mixed vapors to cool, condense and vaporize again. This slow down distillation rate and allows distillation to occur under equilibrium condition. This greatly improves the separation to give more pure distillate but reduces its capacity. Columns used in distillation vary in their shapes and types of packing. Most commonly vigorous or packing columns are used. So that columns are shown in the diagram. First A, that is simple column, which is very ordinary. Inside that there is a tube and two outlets are there connect for water circulation or liquid circulation. Either sides there are two openings of the column. It is called a simple fractionating column. B is a Vegrex column. It is glass tube carrying a number of pairs of spikes. Inside that there are spikes which almost touch each other and which slope slightly downwards. The pairs of spikes are arranged to form a spiral of glass inside the tube. Many other varied shapes are also available. Different shapes also we can use, that is pear shaped or bulb columns, and inside that shown in diagram C, it is a pear shape, D is a bulb shape. These are the Vegrex types of columns. And last type is that is Hempel columns. They are generally packed columns, is called as Hempel columns. It is a straight column packed with glass beads. Inside that glass beads are placed or sometimes metal pieces also used to pack them. This increases surface of contact between liquid and vapor phase, thereby increasing the number of cycles or theoretical plates. Material used for packing should be of uniform size, symmetrical shape and have a unit diameter less than 1/8 that of the column. It should also be capable of uniform reproducible packing. As the size of the packing is reduced, hold up in the columns and rectification efficiently increases sharply. The usual packaging used are generally ring material used or helices also placed inside, or sometimes balls or beads are placed inside that. Balls or beads may be made up from glass material. Helices generally prepared from metal or glass pieces. And rings are there, that is hollow rings present, which are of glass material. Means rings, helices or balls or beads are placed inside this column called as Hempel columns. Okay, these are the 5 types. General number of other types also in available, but here very limited given to discuss. In the next slide you will find number of other columns vigorous I just we discussed. Then cylinder is another column where inside that pear-shaped beds placed. Number of other columns are available which are in use. Now the next type is the types of condensers. We idea about the Liebeck condenser which is available in our laboratory. Condenser, these are the devices used to condense the vapor emerging from the columns while passing it. Any one vapor, suppose liquid is boiled at certain temperature, it converts into vapor. These vapors are the most of the intention behind this condenser is to separate out mixture material from their mixture, and that's why they are used. So condensers means they condense liquids, they condense gaseous form or vapor into liquid. That's why they are called as condenser. Most of the columns provided with water outlets and inlets. One part of that column condenser is connected to water inlet, while another that gives out water called as water outlet. Means two things are there. Cold water is circulated inside that. When the vapor come in contact with this, that is inside there is a packed glass pipe, and water is circulated around this glass pipe. Then that the vapors when come in contact with this water, cold water, it starts to condense. Those which are having boiling points higher than 40 degrees centigrade, because water is at normal temperature, we know that. So room temperature, water is having 20 to 27 or maximum 30 degrees centigrade temperature. Liquid must be above that temperature, otherwise coolant can be used to cool down those which are having lower boiling points. Generally here acetone having 56 boiling point, or say methanol with 65 degree centigrade boiling point, and ethanol with 78, benzene 80, and many other, that is hexane, cyclohexane, they are having the boiling points in that same range, that can be separated using this separating condensers, sorry, not separating, condensers to condense. The role of this condenser is to condense vapors into liquid, and for that purpose these are used. Another B part is that is Liebeck condenser, which is very common. It is available in our laboratory. Air condenser is not there in our laboratory, but we have Liebeck condenser. Next part, that is coil condenser. It is also called as double surface, coil condenser and Friedrich condenser are the two parts of the called as double surface condensers, and it is a tube to which the vapor is condensed between an outer and inner water cooled jacket. After impinging on the latter, it is very useful for liquids boiling below 40 degrees centigrade. So generally these column double surface columns are used for those which are having lower boiling point or near to the 40 degrees centigrade boiling point. Friedrich condenser is a cold finger type of condenser sealed into glass jacket, open at the bottom and near the top. The cold finger is formed into glass screw threads. So this is about the general idea. What are the types of condensers are in use? This is very important to separate out, to isolate two or more liquids or liquid solids together. In their when they transfer into vapor state, they condense into condensers. So this is about the types of condensers, and by this way end of this unit. Thank you very much.